Welcome. In this video, we're going to be practicing our systems of linear inequalities and working through Algebra 2 homework 2.3. I should have a pen ready already. Pardon me. Okay, these first ones, we're just going to sketch the solution set for the system of linear inequalities. And since I'm on a grid, it might be a good idea for me to use a straight edge so that my graphs look nice, right? And here I've got one over here. Okay, so 4x minus 3. Okay, and it's greater than. So I know I'm going to need to draw a dotted line, but drawing a line, y equals 4x minus 3. So minus 3 with a slope of 4 is going to go to 1 and 1. Let's get this lined up just right. 3 up to 1 and 1. That should do it. And then y is greater than or equal to negative 2x plus 3. Okay, so I'm going to go up here to 3, get myself a slope of negative 2. That looks like it's going to do it. And then I'll be right here. Okay. And if I'm above the dotted line and above the solid line, okay, I'm going to be up here and up here. This is going to be this top region here. Okay, that's the solution region. Okay. And then this next one, y is greater than negative 2. I've got this. It's going to be a dotted line. Y equals negative 2. That's going to be a horizontal line. All the points where y is equal to negative 2. Okay. And dotted because it's strictly greater than. We're going to be up here. And then y is also greater than negative 5x plus 3. Okay, that's going to be really steep slopes. It's going to go from here to there. So we're just going to connect these 2 points, and it was greater than or equal to, so I'm going to make this solid. Okay, and if it's greater than both, okay, I want where y is greater than the line and where it's greater than the dotted line, so it's going to be over here. That way. Y is less than positive 3. Okay, we just did one kind of like this, but. And y is less than or equal to negative x plus 1. So it's going to go here, and then it's going to go with a slope of negative 1. So I'll just connect these two. This one's less than or equal to, so it'll be a solid line. And go this way and connect these. Say OK. Less than both of them, so I'm underneath this one and underneath that one. That will be this region here. Right, number 4. X minus 3. Okay, so 1x minus 3, so go down to negative 3, slope of 1. Greater than or equal to means it's going to be a solid line, and okay, it's going to connect these. And y is greater than or equal to, y is greater than or equal to negative x minus 1. So minus 1, and then a slope of negative 1 would go to that point as well. And there we go. Looks like it's going to be pretty good. Okay, both solid because they're both greater than or equal to, and because they're both greater than or equal to, well, we're just going to be on above, right, on both. So. Got that. No, number 5. X is less than or equal to negative 3. Okay, well, x is equal to 3 right here, and all of these points is where x is equal to 3. And so if x is less than or equal to 3, we're okay to the left of this vertical line. And then 5x plus 3y greater than or equal to negative 9. All right, let's see. Are there even any grid points that are... Okay, well, it's going to have a y-intercept when x is 0 of... 3y equals negative 9, so y equals negative 3, so that's a point that would go on there. The x-intercept is going to be, well, 5x equals negative 9, x equals negative 9 divided by 5, that's almost 2. So I'm just going to put it like this, and I mean, I don't think this is even going to fit, right? I don't think they're going to run into each other, but draw the solution region as good as possible. Yeah, okay, fortunately these were both greater than or equal to or less than or equal to. I might just extend this a little bit so that we can at least have them intersecting. It's a little rough. Okay, so this is where if I solved it around and subtracted 5x from both sides and then divided by 3, I would still have y is greater than or equal to, so I'm going to be above this one while to the left of this one, so it's this kind of triangular region here. But it is going to extend forever that way, right? And then, okay, 4x minus 3y less than 9. All right, this one, okay, because that negative 3y, that's going to eventually turn around the inequality. I might just solve for y in this one. Negative 3y is less than, subtract 4x from both sides, and still a plus 9. And then I would divide both sides by negative 3, and I would get just one y. It would reverse the direction of the inequality because I divided by a negative number. Negative 4 divided by negative 3 is 4/3 x. 9 divided by negative 3 is negative 3. Okay, so negative 3 goes up 4 to positive 1 when it goes over 3, so it'll go to that point. And since it's greater than, right there, I'm going to have to make this a dotted line. And then I'm going to cut that with a dotted line. And then x plus 3y is greater than 6. Okay, I'm going to do this one with intercepts because I can see it's still going to be y is greater than. I'm not going to have to divide by a negative number or anything. And x is going to equal 6, the x-intercept. I'm just going to label that right there. And then the y-intercept is going to be 3y equals 6, y equals 2. Okay, so I'm going to connect these 2 points. And I think it should go through, yeah, it should go through that point right there. And, right, and this one's going to be dotted as well. And, all right, so y is greater than the first one, and y is greater than the second one, so we're going to be up here. All right. And there's more. Okay, there's 6 more. Wow, this is a grind. All right, but that's good. You do all these, you feel good about them, you know what you're doing, right? So x plus y is greater than 2. That's, I might solve for y on this one because it would be easy. I would just subtract x from both sides. Negative x plus 2. Okay, and that's a strictly greater than, so it's going to be a dotted line. And then 2x minus y is greater than 1. Okay, negative y is greater than negative 2x plus 1, and then I would divide both sides by negative 1, which would reverse the direction of the inequality, and y is less than positive 2x minus 1. Okay. And so since it's just less than, not less than or equal to, it'll be a dotted line, and I'm going to shade below this line. Okay, so below this one, while above the other one is going to be over here. Okay. This one, all right, not that much different. So x plus y greater than or equal to 2. So we already did that one. That's going to be y is greater than or equal to negative x plus 2. So it'll look exactly the same, except for the fact that it'll be a solid line because it's less than or greater than or equal to instead of just greater than. Okay, and then 4x plus y is greater than or equal to 1. Well, I might just solve for that one. Y is greater than or equal to negative 4x minus 1. Okay, so this one's going to be solid as well. Give it a slope of negative 4. And then I think that's supposed to run in at that grid spot. Let's see if that works. Oh yeah, it did. Okay, and then, what was I thinking? Oh yeah, I got a shade. Okay, so this is y is greater than or equal to, and y is greater than or equal to, so it's above this one and above that one. Okay, it would be easy to be tempted into thinking it was this region, right? Because it looks like the highest up. but it's going to be this one because it's above both of them. And above this really steep line, you got to think, where's y greater? And then that's going to be up here. And so we're going to shade that as our solution region. All right. Okay. 4x plus 3y greater than negative 6. All right, so I'm going to solve for y. 3y is greater than negative 4x minus 6. And then I need to divide by 3. So y is greater than negative 4/3 x. Negative 6 divided by 3 is negative 2. Okay, so negative 2 goes down 4. Okay, I can probably do that when it goes over by 3, so it would be about here. Okay, but I want my graph to be as accurate as possible because I'm on a grid, right? So if it goes over 3 down 4, it's got to go over 3 the other way up 4. And that'll be on the grid 1, 2, 3 up by 4. And if I aim for these two, that'll give me a little something better. I tried to avoid doing that because, you know, it's kind of needlessly confusing. But on this one, you know, where you're kind of having to eyeball a grid spot, that's not good for making accurate graphs. So since this is greater than, I'm just going to make it a dotted line. And okay, I did hit that spot, so evidently I guessed well. But okay, there we've got a good picture of that inequality. We're going to shade up above, right? And then x minus 3y is less than or equal to negative 9. Okay, well that's going to be troublesome because I don't have x equals negative 9 available over here. So I'm going to need to solve for y and then do the best I can, right? So now I'm going to go over here, and this is going to be negative 3y is less than or equal to negative x minus 9, right? When I subtract x from both sides. And then I will divide both sides by negative 3, and that will reverse the direction of my inequality. Negative 1 divided by negative 3 would be 1/3 x, and negative 9 divided by negative 3 is positive 3. Okay, so positive 1/3 x would go over here. And okay, fortunately, I've already got that spot marked. Looks like it's going to go through that. Also, this is greater than or equal to, so I'm going to need a solid line. And I will just go in and, okay, that wasn't the best ever, but it's good enough, right? And so it's greater than the dotted line while greater than the solid line. Also, that's going to be this region up here. All right, y is less than negative 2. Okay, well, y equals negative 2 is over here. And x plus y is greater than or equal to 1. Okay, if I was to work this around, I don't think I'm even going to write it down. I would subtract x from both sides, and I would have y is greater than or equal to negative x plus 1. Okay, we'll go to the y-intercepts. Negative x is a slope of negative 1. And so I would go and I would connect these two. And since it's greater than or equal to, I'm going to use a solid line. That'll do. Just a little bit. Hope for the best. Yeah, there we go. Looks pretty good. All right, and now it's y is less than negative 2, so we're below this, while above the line. So above this, so below and above, that's this little region down here. All right, 3x plus y, these all seem so similar, but I know they're all just slightly different. I don't think I've done the same one twice. So, hold on just a second. So this next one, we're going to say, all right, 3x plus y greater than or equal to negative 3. I'm going to solve for y by subtracting 3x from both sides. Y greater than or equal to negative 3x minus 3. Okay, again, this is one that's going to go off of the grid. So it would go down here to negative 6, wherever that is. But I could go the other direction as well. So over 1, up 3. And that would give me a little something better to aim at. So go through here, really focusing on those upper 2 points. And if I run into the third one, great. If not, then I missed a little bit, right? And that's okay. Okay, I didn't check, but it's greater than or equal to, so I'm all right. It's solid line. Okay, then x plus 2y is less than or equal to 4. Okay, this is going to be y is less than or equal to, and maybe I'll do intercepts on this one. X is going to equal 4. 2y is going to equal 4, so y equals 2. And then I will just connect those with a solid line because it's less than or equal to. Looks pretty good. I think it's supposed to run into each other there. One of those. Okay, and so this is where y is less than or equal to. If I was to solve it out, yeah, I know that wouldn't be divided by a negative number, so it wouldn't change the direction of the inequality. So I'm going to be underneath this one while above that one, so it's going to be in this region here. Okay. And then the last one, x plus y greater than or equal to negative 3. Okay. So that's y greater than or equal to negative x minus 3. And then this one is y is less than or equal to negative x plus 3. Okay, so this is going to make not a parallelogram, but something that looks like that. A strip of area. Okay, so it's greater than or equal to and less than or equal to, so I'm going to draw these solid lines. Okay. And it would make sense that they're parallel because I'm seeing x plus y on both of them, so they're going to have the same slope. And of the one with the negative y-intercept and below the one with the positive y-intercept. And so I shade through here. Okay, one situation that we have not run into is one like this. If this had been y is like the opposite directions, y is less than or equal to negative x minus 3 and y is greater than or equal to negative x plus 3, then there would have been no solution because there was no overlap. And I'm realizing that we have not run into that scenario. But, you know, probably not something I'm going to test you on, right, if I haven't brought it up yet. But probably something we should have talked about. Okay, so, I don't know. Maybe we'll do a practice problem at the beginning of class talking about that. And now we will write a system of linear inequalities whose solution is the set of points in quadrant 2 not including the axes. Okay, so just to remind you, it's like 1, 2, 3, and 4. So if we want this area, what we're really looking at is something like this. Right? And so this is where, well, the thing about quadrant 2 is x is negative and y is positive. So since these are dotted lines, I think I'm just going to say x is less than 0 and y is greater than 0, right? If these are my x and y axes. Okay, then that would be the solution region. Okay, that was an interesting question. Don't remember putting that one on there. Write a system of linear inequalities to represent the graph below. Okay, now I don't see, I'll do the 2 lines. I don't really see that same darkness up at the top to indicate that this is stopping at y equals 5, but I'll write down an inequality that would show you if it was there and it was a solid line what we would do, because I think that the ones that I'm going to ask you to do on the quiz and the test, I think they do have 3. So right now what I can see, I know this one is y, this line would be y equals negative x, because the slope of negative 1 minus 2. But we're above this dotted line, so it's going to be greater than. And it's just going to be greater than because of the dottedness. Okay, then over here I've got a solid line. The slope is 1/3. And the intercept was 3. And we're above the solid line, so it's greater than or equal to. Now, you know, that's not really what I'm seeing here with y equals 5. But had there been one of these, that then, you know, kind of like said, okay, that's where the edge of our solution region is, then we would have said, oh, okay, this is y equals 5, this line, and we're below it, so that would be y is less than or equal to 5. If you saw the solid line there, which you very well might soon. All right, now we'll find the area of a solution region for the system of inequalities. Okay, I'm going to have to pull up the original because there's a hole punch on this, and you know, I'm sure yours is hole punched as well, and we're just not sure what, if it's just x plus y equals 5, or 1x plus y greater than or equal to 5. Okay, just had to make sure. And, all right, so this is just x plus y. So I'm going to sketch it, and I'm going to have a y-intercept of 5, x and y-intercepts of positive 5. Okay, but then a y-intercept of negative 5 down here. So I'm going to need positive and negative y. Pretty much only need positive x, though. Okay. So I'm going to mark off 5 here. And since y is less than or equal to 5, I'm going to go in and just give it a solid line here. And while finding the area of a solution region, not exactly something that we're going to have to do on this unit's test, it's something that we're going to have to do in the next unit. We're going to find the area of trapped between a graph and the x-axis. So it's good that we're starting to think about our area formulas for triangles, trapezoids, things like that. Okay, x plus y is greater than or equal to 5. Well, that's going to have an x-intercept of 5 and a y-intercept of 5. So I'll go here, I'll go there. It's greater than or equal to, so I'm going to say, all right. This is going to be a solid line. Okay, yeah, the next one, I don't need that much more. Because I can see what the x-intercept of the next one's going to be. It's also going to be 5, so I think it's going to make a triangle. And that'll be nice. Okay, so 5x minus y less than or equal to negative 25. I'm going to find the intercepts. Y, or x, 5x equals 25, x equals 5. Okay, so I'll put that there. Negative y equals negative 25. Oh, goodness. I didn't really realize this. I'm going to have to make 25 that. Okay, that's as far down as I can reach. Okay, and it's probably not drawn to scale, but that's okay because I'm not on a grid. So I'm just deciding that's 25. This is going to be 5. And we'll just draw it like that. The issue, since I'm not on a grid, is I need to find out what is the x-coordinate of this point so I know what the width of the triangle is. Right? I know the height is going to be 5, but the width is something more than 5, and I don't know exactly what it is. So I need to find the x-coordinate of this using substitution or elimination. So So what we're going to do is we're going to say what ran into each other. Y equals 5 and the steep line, 5x minus y equals 25. Okay, so we're going to solve the system y equals 5 and 5x minus y equals 25. And I think I'm going to use substitution, right? I'm not going to use elimination on this. There's no point. Okay, I'm going to say 5x minus 5 equals 25. Okay, then I'm going to add 5 to both sides, and that's 5x equals 30. I'm going to divide both sides by 5, and I get x equals 6. Okay, so I've got my x-coordinate. It's 6. So I now know that the width of the triangle is 6. Blue will be fine. The height, well, it's the distance from y equals 5 to the x-axis, which is y equals 0. So that's going to have a height of 5. Area of a triangle we know is 1/2 times the base, okay, which is 6, times the height, which is 5. So it's half of 30, which is going to be 15. Okay, that was a good problem. Which quadrants in the xy plane are going to contain solutions to the system below? Okay, you are going to be confronted with a multiple choice question very similar to this pretty soon. Okay, so just be aware of that. If I don't know any better, I'm just going to give myself all 4 quadrants to work with. 1/2 x plus 3. I'm going to mark 3 there. 1/2 x, well, it's, not very steep. So I'm say it's maybe like that. And this is greater than or equal to, so it's going to be a solid line. Okay, and then 3x minus y is greater than 2. Okay, so that's going to have a y-intercept of negative 2. And an x-intercept of 2 divided by 3. So really right there, maybe. I don't know. Probably not drawing scale. I'm going to move that. I'm realizing that I need them to intersect visibly on the kind of region that I've drawn. So I'm going to make 2/3. Decide where the intersection is going to be first, yeah, and then 2/3 will just happen where it happens, right? So I'm just going to decide it's going to be like this, because yeah, if I was to solve this back around, I mean, you can see from the signs of the intercepts, if I was to solve this back around for y, I would have a positive slope, and the slope would be, I think, positive 3. So it's going to be pretty steep. And, okay, I forgot to make this dotted, but maybe you've done that at some point. And, I'm working in pen, so that makes it a little harder. But, I can always come back through with my eraser, especially if you're working in pencil, and I can just go over parts of the line and turn it into a dotted line. That's not the best dotted line I've ever drawn, but it'll do. And so if y is greater than or equal to the solid line, and then would flip around, so it would be, if I was to solve for it, I'd have negative y is greater than negative 3x plus 2, and I'd divide both sides by negative 1, which would reverse the direction of the inequality. Okay. And I forgot what I was thinking here. Oh, yeah, it would be less than the dotted line. So beneath the dotted line, while above the solid line, that's going to be over here. And so which quadrants contain solutions? Well, just quadrant 1. Okay, or quadrant 1 only. Let's see. Are there more on the back? Yes, there are. And, okay, it's good if you're still watching that you're still watching, because there's a free response problem on the test very similar to this one. All right, so the Ross family won a raffle of $1,000 to spend at the amusement park. They want to use it for a group tour and for meals. Tour can have at most 8 people in the group, and if there are children on the tour, then there must be at least 1 adult. Okay, the tour costs $250 plus $100 for each adult and $50 for each child. And then the meal plan is $15 per person. That's a whole lot to take in. Okay, and so x is going to be the number of children and y is the number of adults. Okay. A tour can have at most 8 people in the group. So they can have 8. So x plus y is no more than 8. So that's going to be x plus y less than or equal to 8. Okay. If there are children on the tour, then there must be at least 1 adult. Okay. And let's say that there is this is interesting, that if there is a child, okay, so I guess I'll say if x is greater than or equal, because x is children, right? Yeah. If x is greater than or equal to 1, then y is also greater than or equal to 1. Okay, so maybe when I sketch the graph, I'll know what to do with this. Okay, the cost of the tour is $250, and this is at most $1,000, right? So something is going to be less than or equal to 1,000. Okay, I think it's going to be $250 plus $100 for each adult. That's 100 times y. 50x. And then the meals, well, that's going to be $15 for each adult and each child. So I guess I would say 15 times x plus y. I kind of boxed myself in there. And that's going to be the total amount of cost. Which is like a pretty complicated cost scenario. But, sorry. Yeah. So this is going to we're going to need to do some work on this, right? So I'm going to say, how many total y's do I have? I have 100, and then I'm going to end up having 15 more. So 115y, still going to be less than or equal to something. Okay, and then I kind of lost where I was. Oh, I had 50x and then 15 more x's. That's going to be 65 total x's. And then I'm going to need to subtract 250 from both sides. And man, not loving these numbers, right? I'm not sure that 750, I'm pretty certain that 750 is not divided by 115. So, all right. We'll be brave. We'll sketch a graph here. But, this is not the type of graph I would ever expect you to sketch on a quiz or a test. So I'm going to do something different real quick. All right, we really haven't had occasion to use graphing calculator in this class yet, but I feel every time it would be now, and my graphing calculator has very low battery because I haven't been using it much, right? So if I want to graph these things, I need to solve for them y in terms of x. And I'll do it. Okay, that's definitely not for this class. If x plus y is less than or equal to 8, I would solve for y, and I would get y is less than or equal to negative x plus 8. Okay, hold on, I got somebody else at my door. And then I guess if I was to solve for y on this other inequality, I have to do some algebra, right? So I'm going to solve for y. I'm going to subtract 65x from both sides. Less than or equal to negative 65x plus 750. And so I would solve for y by dividing everything by 115. Okay, I mean, obviously it can reduce. They're both multiples of 5, but I don't know how it would reduce. Okay, put that there. And then plus 750 divided by 115. Okay, so this actually shouldn't be, too far off of our standard window, but I'll show you what I mean here. So anytime with a fraction, I recommend pulling up the fraction bar, and so we do that by hitting the green button and y equals, right? So that's going to give us f1. We call for numerator and denominator. So negative 65 divided by 115 times x plus, call for another fraction, so f1, first option, 750 divided by 115. Okay, now we're going to graph both of these, and that will at least give us a picture, something to look at. Okay, hoping for the best. Okay, that looks pretty great. I'm going to adjust the window a little bit so we can figure out what the x-intercept is over there, but actually, it doesn't even matter. I'm going to show you why. So, when I go over here to sketch the graph of your system, our system. Okay, we're really not interested in all this stuff where x and y are negative. So maybe I will say that x minimum is 0, x maximum of 20, y minimum of 0, y maximum of 20. And then there we can see, right? Because we're not interested in negative numbers of people going to the amusement park, right? That's not realistic. So I'm going to go over here to sketch a graph of my system. So this is the x-axis and the y-axis. And I know, okay, the blue line is kind of the line that's dictating our cost. And that was x plus y, or no, not our cost, the limits on the number. Realizing you can't see that now. I'll zoom out again, yeah. My computer's in the way. And then, okay, so the blue line represents costs. I mean, not cost, total number of people. Maybe I'll leave it like that. And then the red line represents the limitations on cost, right? The cost has to be less than $1,000 or equal to $1,000. So it starts off a little bit less, and then it goes over to a point where it's greater. And then since both of them are y is less than or equal to, positive y is less than or equal to, I'm going to say that's my solution region. So I might be interested in the coordinates of their intersection. Okay. And then this intercept and that intercept, right? Really it's the corner points that we'd be interested in these like applied system of inequality problems. So in order to find these, okay, well the y-intercept of the red line was cost, so that was over here. Okay, and I used blue, that was probably a poor choice, but 750 divided by 115. Okay, that's 6.5 adults. So 6.521. We're going to eventually round to 3 decimals in the class, so might as well start now. And then over here, this was x plus y is less than or equal to 8, so I know this is going to be 8 and that's going to be 8. What I'm really interested in is this intersection point right here. And I'm going to use the calculator to do that for me, right? So I'm going to go over here. I'm going to calculate. That's where all the good stuff is on this calculator, at least for algebra-based classes. So we're going to call on calculate using the blue button because it's written in blue. And then I'm going to find the intersection of the first curve, which is blue, and the second curve, which is red. It's going to ask us for a guess, like where do we think it's intersecting? And this is really for if it's intersecting more than once. It's like where should I start looking to find the first place they intersect? And then I'm going to have, this is where x is equal to 3.4 and y is equal to 4.6. Okay, I'm starting to see what they're saying here. Because what I kind of forgot about was if x is greater than or equal to 1, then y needs to also be greater than or equal to 1. So if this is 1, okay, pretty much what we're doing is we're carving out the only kids area. That's not allowed, right? So we're going to lose this part of our inequality. So it's really going to be like this. Okay, so we've like kind of carved out that region from our inequality space. But over here, this is where we're not taking anybody, and this is where we would be taking just. Okay, so this would probably be dotted, I think, right? Because we can't take one child and no adults. This whole thing should be empty. I don't know. I'm not going to think about that too much because of the discrete nature of this problem. You know, with there being only whole numbers of people, I think that's not a problem. Anyway, let's not overthink it. What's the maximum number of people that could be in the group, and what would it cost? Okay, that would be I've got 6 people here because I can't take 6.5 adults. I can't take 8 kids and no adults. I know this is going to be more people than that. That would be 7 and 1. Oh, no, that is going to be this corner spot is going to be the maximum number of people. And I've got somebody at my door, so I'm going to have to. Okay, because this point right here, this is going to be the point where x is 7 and y is 1. And that's a total of 8 people. Here we would have to round down, right? We can't take 3.4 children and 4.6 adults. And so we'd have to round down to 3 and 4. And that would be 7 total people. Over here I can take 6 total people. This is not allowed because I'm not allowed to just run out 8 children. Okay, with no adult to accompany them. So we will be, we'll be saying, okay, the maximum number of people in the group would be 8 people. And then the cost would be 7 children, 1 adult. Well, let's see, the cost function was all the way back up here. It was this long string. So cost would be 250 to show up, 100 times the number of adults, which was just 1, and 50 times the number of children, which was 7, and then $15 for each person that went, which is 15 times 8. So this is going to be 250, 350, that'd be another 350, so that's 700, and then 15 times 8. It's 120, so it would be $820. Okay, if only adults are going on the tour, how many can there be? I think, okay, that's where x is 0, so that would be up to 6. But not 7, right? Because 7's outside of our solution region. 6.5 was the limit there. All right, that's going to be all for this video. Thanks for watching. Hope it helps.